Hello friends, my name is Tulendra Thapa and today I will be teaching you about numerical methods. Tomorrow is my test, so I thought this would be a good time for me to revise and also to share some knowledge to my fellow mates in this world who are also struggling in this. I am a physics honor student, second year student from Ramjas College, Delhi University. So now let's get started. Sorry for my hand being shaking, and also please don't be judging from my hand appearances. uh, there are some reasons because my hand that's why some reasons because why my hands appear like this. So get started. Numerical methods. Firstly, we have bisection intermediate value theorem. In this we have a function fx and we are given 2 points a comma b, and if we put fa and we put fb, and if we multiply both of them and we see that their multiplication is less than 0 or negative, then one or odd number of roots lies between these two intervals. Simply, I will try to be fast and very narrative, so I will not write these now. You can simply now see that uh, we are going to bisection method. Simple, very simple, very easy. Firstly, we have two will be given 2 points a and b. We will check whether if a into fb is smaller than 0, then we will, if this condition is met, then we will say that there would be one or odd number of roots in this interval. Roots are the points where it goes x-axis. This is also important. The matlab, this means that it will cut either one time between a and b or odd number of times, not even number of times. uh, Simply just remember that there will be a root between this interval if fa into fb is smaller than 0. Now for iterations in bisection method, we have c is equal to a plus b by 2. For finding midpoint from this is simply finding the midpoints of both of them. So now we would have fa into fc. This would be a new point. Agar if this is less than 0, then this is a new interval, and if this is less than 0, then this would be a new interval, and we will find iteration like if we have this condition, then b plus c by 2 is equal to the d. This will be a new point. Simply we will go up to desired number of iterations, and we will write the answer as this term. This will the d or c would be the term, or the midpoint will always be the final answer, not the points on the sides. That's the point to remember. Now we will see secant method. In this methods, numerical methods, we just have to mainly learn formulas. In secant method, we do not have to remember the intermediate value theorem. We do not have to follow the intermediate cancel simply. Now we can simply say that the new iteration, new point would be given by like this: xk plus 1 is equal to xk. Simply, how to learn this formula: xk plus 1 is equal to xk minus 1 upon the thing that is above. You can simply put f on both of them and put f of this here. Simple, very easy. Now we can find the iterations, and we will go on till we find the desired answer or desired number of iterations. Do the desired number of iterations. Regular falsi method, this is nothing. Regular falsi, we can say that it is simply secant method plus intermediate value theorem. It is very easy. Secant method plus intermediate value theorem means that the root that we will get here, from here we will now have to check fxk plus 1 into f of xk is smaller than 0, or f of xk plus 1 k plus 1 f of x and this k minus 1 is smaller than 0, then 2 points given to us will be xk and xk minus 1. Simply we have to check this and we have to go forward again. If we have these two, then we will apply the formula in these two and obtain the new interval. If we have these two, we will apply the formula of secant method in this and obtain the new interval. New interval, not new point, and then again we will do this and find the new interval. And Newton-Raphson method is by far the most simple method I found. Newton-Raphson simple method, I suppose, because in this we do not have to look into anything or into no intermediate values, no nothing. Simply formula xk plus 1 is equal to xk minus fk upon fxk upon f of xk, f dash k. Simply very easy. Now we will see simply how to solve the system of equations like this ones. If you are following the numerical method course, then this would have come across, you would have come across this augmented matrix. This is called augmented matrix. This is very useful in this scenarios in this numerical method course. Simply we would go through very easy. There are two methods to solve system of equation: direct method and indirect method. In direct method we have Gauss elimination, and we have Gauss Jordan, we have here Gauss. In the indirect we have Gauss Jacobi and Gauss Seidel. Now in Gauss elimination we simply have to like this. We have make the augmented matrix. Augmented matrix is very simple. Just we have x y z x. We have x plus y plus z, 2x plus y plus z. Then 1 1 1 मतलब x coefficient, y coefficient, z coefficient, and here the answers है ना. Simply very easy. Equal to this. This would be the this matrix. We have to put equal to here. Means negative can also come. Means that we have to put 2x plus 2y is equal to plus 3z is equal to this, and then we have to put into this equal to के उस तरफ. We don't have to put, I suppose we don't have to put here 0. We have to have the, if we have 0 then we can have 0. मतलब I am trying what I am saying, you are understanding ना. मतलब if we have minus 27 like, तो plus 27 is from going equal to this side, so this is 27. We have to simply make this matrix, and there comes partial pivoting. This partial pivoting is nothing but bring the largest element of this here in the first point place, and then simply put this equal to make this equal to 0, this equal to 0, and this equal to 0. This will make a partial pivoting completing, and this will also make the Gauss elimination method completed, because in Gauss elimination method we have to make upper triangular matrix. नहीं upper triangular matrix है ना. We got the upper triangular matrix, and if we get upper triangular matrix, we can use this term, this process of this term. Try to write this term back substitution. It is very simple. Z is equal to this, then put Z is equal to y, Z के term यहाँ होंगे, there will be y z terms here and x y z terms here. We put back substitution, we got the value of z. Now we will put z in here, and we can further get the values of y and further get the value of y, and after this we can put the value of y and z in the above equations, and we could get the value of x, y and z. Now simply we have the result, and this is Gauss elimination method. In Gauss Jordan method we try to make identity matrix, or so that we have 1 1 1 0 0 0 0 0 0, and here we have the values. Here simply we get the answer like x is equal to this, y is equal to 6, z is equal to this. So Gauss Jordan method is also very simple, and here we do not have the concept of pivoting. Pivoting only comes into action in Gauss. Partial pivoting is only in a syllabus mainly. That also only comes in Gauss elimination method. Simple. Now we will see the Gauss Jordan method, Gauss Jacobi method. In Gauss Jacobi and Gauss Seidel I will explain simultaneously. Gauss Seidel. In this we have system of equations that x plus y plus z is equal to 2 3x plus y plus z is equal to 4, 2x plus y plus z is equal to 10. We will simply put x is equal to 2 minus y minus z, y is equal to 4 minus z minus 3x, z is equal to 10 minus y minus 2x. Now simply we put the initial condition 0 comma 0 comma 0 for x y z, or the given conditions. If not given, we will use this. Remember that if not given, we will use this, and we will obtain the value of x1, y1 and z1. And in the next iterations, we will use the initial conditions of, like, we will use the initial condition this and find the value of x2, y2, z2, and in the next one we will find the value of x3, y3 and z3. Simple. But now in Gauss Seidel, we upnotch this a little bit. We write that x1 is equal to 2 minus y minus z. Simply these are initial values. Now y is equal to 4 minus z minus 3x1. This comes here. Matlab, in this we are taking iterations inside iterations. Matlab, we are using the modified values of iteration in the new one. This is very simple. When you get used to it, just try one question. Just try one, only one, or just see this only. If here we will use this, and here 2x1, because these are the new modified values. We have to modify the values, and this would be y1 and this would be z1. Now these values will be used in the next iteration. Thus Gauss-Seidel method is very much faster, converges to the answer than Gauss-Jacobi method. It is now, hence both the four methods are very simple. You can just simply see this. And now we will find the rate of convergence of different methods. Rate of convergence in the thing, it is largest positive number largest positive number that follows this. ek plus 1 is equal to ek mod of ek plus 1 is equal to cek ki power k, and this k is a positive largest number, which is also called the rate of convergence or order of convergence or rate. I suppose I also have test tomorrow, so I'm also revising. This is known as rate of order convergence, and this is the error in the x power xk plus 1 term. So matlab xk plus 1 minus epsilon, the value of the root. And we find rate of convergence for methods like secant method, Newton-Raphson method, and the bisection method. Bisection method has one which is very simple. I will do for 1.618 secant method, and secant method and the secant method and secant method and regular Falsi method have the same formula, hence they have the same rate of convergence. And we have rate of convergence of Newton-Raphson method, that is comes out to be 2. Now we will see how these questions are generally asked. Newton-Raphson, I suppose, and secant method, because regular Falsi method is same as secant method. Now ak plus 1 is equal to xk plus 1 minus epsilon naught, and ek would be then xk plus xk minus epsilon. Epsilon will be same, because this is the true root, and true root value would not change if we have given it the same intervals, है ना? So now first we will do for secant method. Secant method, we have these two values. Now we have the formula xk plus 1 is equal to xk minus xk minus 1 upon f of xk minus f of xk minus 1 f of xk. Simple, easy. Now we will put these क्या बोलते हैं, these form, these क्या बोलते हैं, now we will put the values of ek plus 1 xk plus 1 xk from here and here into here, from here to here to in here. So we will try to put it and solve it. E की power k plus 1 plus epsilon, we can simply see this k plus 1 plus epsilon is equal to, what we will put, e की power k plus epsilon minus, and here we would have e की power k plus epsilon क्या बोलते हैं xk minus 1. xk minus 1 would be e की power k minus 1 plus epsilon. Simple. We can see it here, then e की power k minus 1 is equal to x की power k minus 1 minus epsilon, है ना? Simple. We have put it here and divided by f of e की power k plus epsilon. Here the fun part begins. Minus f of e की power k minus 1 plus epsilon, and we have in multiplication e की power k plus epsilon. So now we have to solve this. It is very looking difficult, but I also learned it and you should also learn it. So it is very easy. It is very easy. By the way, if we learn it, e की power epsilon to epsilon cancel. So now we have e की power k plus 1, and here also epsilon cancels out. तो e की पावर k is equal to e की पावर k minus e की पावर k minus e की पावर k minus 1. Simple mathematics here. E की पावर k plus epsilon minus f e की पावर k plus 1 plus epsilon f की पावर e की पावर k plus epsilon. Now simple we have f of xi, no, f of epsilon plus epsilon k है ना. Simple, I am writing simple, easy. This is also called Lorentz नहीं, Taylor series expansion. This we would have studied in mathematical physics or simple mathematics. Simply we have, I am studying from Bisection Method, so I have studied in mathematical physics. This is known as Taylor series. We can simply, it is also used in numerical methods, differentiation. So I have learnt it. So first we will write e की power f e epsilon plus epsilon k की power 1 factorial epsilon ये differentiation हुआ plus epsilon k का square upon 2 factorial f double dash epsilon plus epsilon k का cube upon 3 factorial f triple dash epsilon, and so on. You got what I am trying to say. Now we will simply put the values and put this in the equations. ek minus 1 upon, if we do this, then f of epsilon plus epsilon k f dash epsilon plus epsilon k का square f double dash epsilon upon 2 factorial, and so on. And in here we will have same epsilon k का square f dash epsilon, you can fast forward a bit, upon 2 factorial f double dash epsilon है ना, and dot 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 minus, and here we would have x minus 1 epsilon minus 1 e minus 1, there is some error, here minus 1. So now we would have simple f epsilon will be still there, e k minus 1, everywhere k minus 1 k minus 1 k minus 1, so plus e की power k minus 1 upon 1 factorial f epsilon f dash epsilon plus e k minus 1 का square upon 2 factorial f dash epsilon, and dot 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 dot. Now f epsilon would be equal to 0, and why would this would be 0? Because epsilon is the 2 root, and if you put root in any equation, then its value comes to 0. And any function, root of any function in this function itself, then the function gets to 0. It is very simple mathematics. Please try to understand what I am trying to say. It's very late in night, but I am still studying. I need some motivation, so I am trying to give it to you all also. So try to grasp as you can. Now simple, k plus 1 is equal to e k minus 1. Try to learn the n terms of this. Write this much formulas in the test, and you will be good to go. And try to learn it simply. I can't say anything else. F epsilon is equal to 0, and we would have epsilon k dash f dash epsilon plus e k 2 dash e k square e की power 1 e k square f double dash epsilon upon 2 factorial, and this will go on, and we would have here e की power k का square upon 2 factorial e की power k f dash epsilon plus e की power k f double dash epsilon square upon 2 factorial plus dot 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 dot, and here we have minus e की power k minus 1 upon 1 factorial f dash epsilon plus e की power k minus 1 square upon 2 factorial f double dash epsilon, and so on. Here we go. From here we would simply have e की power k plus 1 is equal to e की power k minus e की power k minus e की power k minus 1, and we will take common e की power k f dash epsilon 1 plus e की power k f double dash epsilon upon 2 factorial, and if we have taken this common, so this has square and this would remain e की power k and f dash epsilon plus dot upon, and here we would have e की power k minus e की power k minus 1 f dash epsilon. If you see the, here we have this common and here we have this minus, here minus came, e की power k minus 1 epsilon k, plus we have e k का square minus e k minus 1 का square upon 2 factorial f double dash epsilon, and this would go so on and on and on. From here we have e k plus 1 is equal to e की power k minus e की power k minus e की power k minus 1, and we have taken out common e की power k f dash epsilon, so we have 1 plus f dash epsilon f double dash epsilon upon f dash epsilon, and here we would have e की power k and 2 factorial, I suppose 2 factorial dot, and here and down here we would have e की power k minus 1 f dash epsilon plus e की power k का square minus e की power k minus 1 का square f double dash epsilon, and here we would have 2 factorial plus dot. From here we can say that if we take out common this, then this and this will cancel out, simple, and we would have e की power k minus e की power k minus e की power k minus 1. Simply rewriting these terms, you can fast forward here a little bit, and we would have 1 plus f double dash epsilon upon 2 factorial f dash epsilon k dot upon, here we will write e की power k minus e की power k minus 1 and f dash epsilon, take this common out, and we would have e की power k plus e की power k minus 1, here a का square plus b minus b का square is equal to a plus b minus a minus b, a plus b into a minus b, and here we would have f dash epsilon upon f dash epsilon, and here here we have 2 factorial, everything correct so far, dot. This is series are going to infinite. e की power k plus 1 is equal to e की power k minus e की power k minus e की power k minus 1, and here we have no, first we will have to cancel out these two terms f dash now we would have to not write this again, so simply e की power k 1 plus f dash epsilon k upon 2 factorial f dash epsilon dot into 1 plus epsilon k plus epsilon k minus 1 upon 2 factorial f dash epsilon upon f dash epsilon, simply plus dot. Now we have this power minus 1. Now 1 plus x to the power minus 1 is equal to 1 minus x plus x का square minus x का cube if x is smaller than 1. Here x is simply would be smaller than 1 because e की power k is error, and error has to be very low, and also we have the error in here, so this would be multiplied, this will come 0.00 something, and this multiplied by this would be very small, simply meaning that this is smaller than, and we can use binomial expansion here, sorry, e की power k minus 1 plus f dash epsilon upon 2 f dash epsilon k dot into 1 minus epsilon k plus epsilon k minus 1 upon 2 factorial f double dash epsilon upon f dash epsilon dot minus 1. Now simply we multiply both these terms, and then we will simply neglect higher term powers, we would have 1 plus 1 minus epsilon k plus epsilon k minus 1 upon 2 factorial f double dash, and we would have epsilon k here multiply also here from here. So we would have f dash epsilon upon f dash epsilon, this multiplied by this multiplied by this, and this multiplied by this, and this multiplied by this. We are not taking extra other terms here, that is dot 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 and dot dot, because they would get neglected, because higher term powers of e की power k, which is error, and error is smaller than 1 and generally smaller than 1 na. We took error, we took error very small than 1, very small than 1, try to minimize it as much as we can. So it is simply simple logic that it will be very small than 1, and small, if we must square smaller numbers, it will get more smaller, it will get more smaller, 0.02, 2 upon 100 ka square, 4 upon 100 into 100, simply 0.0004 I suppose, है ना, 30114. It will be very negligible. So we will write this plus f dash epsilon upon 2 f dash epsilon epsilon k, है ना, multiplied by this minus this multiplied by this, we would generally neglect it also, I suppose. I messed up though a little bit. I messed up the little, I suppose. What did I messed up? Yes, I made a new discovery that I have been learning it wrong. So now I will correct it. Simply, there are two corrections. Simply, first on this one, epsilon k plus 1 is equal to smaller than equal to not is equal to c epsilon k mod, and here also, array, I can't see because I am recording. Epsilon k to the power p, and this is the order or rate of convergence. And now from here we could see, we are multiplying, and we would see that e की power k plus 1 is equal to e की power k minus e की power k 1 plus f double dash epsilon upon 2 f dash epsilon into epsilon k dot 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 1 minus e की power k plus e की power k minus 1 upon 2 factorial f double dash upon f dash epsilon epsilon dot 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 dot, and we will have this. So now we will have e की power k plus 1 is equal to e की power k minus e की power k 1 plus f double dash epsilon upon 2 of f dash epsilon e की power k. This we are cross multiplying, and we are not cross multiplying rest of the terms because they will multiply and give rise to e की power k into e की power k, that is root into root, no, sorry, error into error, and error is always less than 1 by simple logic. Error has to be less than 1 for having better answer. So with multiplying higher terms, order terms with higher order terms of this, we will have error that is very large, that is 0. For example, error is this, so 2 upon 100 ka square is equal to 4 upon 100 into 100. So error will be very large, hence we can neglect the higher terms. We will neglect the terms later on. First we will have to multiply this, so we multiply this with this and this with this, and now we will multiply this into with the last term, that is e की power k plus e की power k minus 1 upon 2 factorial f double dash epsilon upon f dash epsilon plus this into this term will be neglected, simply neglected, because it will have power that is greater than 1, no, power the power that is greater in value number, and simply error multiplications would be lead to finite, it is lead to being it very small and negligible. So now we would have e की power k plus 1 is equal to e की power k minus e की power k, and here we would have 1 plus 1 minus, here we can see that e की power k half 2 factorial is 2 or half double dash epsilon upon epsilon. So this term and this term will cancel out, simply we will get 1 upon 2 factorial e की power k minus 1 epsilon k, no, not epsilon k because it has been cancelled out, epsilon k minus 1 f double dash epsilon upon f dash epsilon. simply and neglect it. And here we can neglect the higher order terms, higher power terms of e की power k comma e की power k minus 1, as these are error and these will get neglected. How simple. Now e की power k plus 1 is equal to e की power k minus e की power k minus 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 plus 1 upon 2 epsilon k minus 1 epsilon k f double dash epsilon upon f dash epsilon. Simply we have this cancelled out. To e की power k plus 1 is equal to 1 by 2 e की power k e की power k minus 1 into this is into k minus 1 and f double dash epsilon upon f dash epsilon. Now simply we will take these terms and not e की power epsilon, this will remain like this. Now we will simply take these terms and put them equal to c or any constant or a, whatever constant. Here we have the constant, and this constant I forgot, it is also called, it is called something, it is called asymptotic, and after that it has it had, I suppose, asymptotic error constant, I suppose. Now e की power k plus 1 is equal to c or a e की power k minus 1 है ना. Now I forgot something. Now we can write e की power k plus 1 is equal to c e की power k की power p है ना, and e की power k minus 1 is equal to c e की power k c की power k is equal to k minus 1 की power p. We will put this and we will put value of e की power k minus 1 की power k minus 1 is equal to e की power k c minus p, and here it will go minus p and here 1 p. This two in this equation. We had e की power k minus 1 c, and we have e की power k minus 1 is equal to c minus 1 upon p, e की power k 1 upon p, e की power k 1 upon p, and e की power k plus 1 is equal to c e की power p. So now putting these values here, c e k की power p. Now we would have e की power k e की power k will remain like this, c will remain like this, c की power minus 1 upon p, e k की power 1 upon p. This and this would add e k की power 1 plus 1 upon p. This and this would add c की power, no, c and c would cancel out, and c would have 1 upon 1 upon p is equal to e की power p. Now we will simply p is equal to equate the powers of e की power k. I am a little tired because it is late at night, 1:30 I suppose, or 2 a.m. So now p is equal to 1 p plus 1 upon p का square है ना, p plus 1 upon p. So p का square minus p minus 1 is equal to 0. Now सीधी तरह से RS formulas minus 1 minus plus minus minus 1 plus minus under root minus 1 का square minus 4 into 1 into minus 1 upon 2 into 1 is equal to x is equal to this. So p is equal to मतलब, so 1 plus minus under root 1 plus 4 upon 2 is equal to 1 plus minus under root 5 upon 2. Now we have defined that p to be positive, and so we will take 1 plus root 5 upon 2 and we put this in the calculator. You would have 1.618. You simply have to learn this 1.618 1.618 1.618 1 plus root 5 upon 2. And simply after coming here we have to put e की power k plus 1 is equal to c की power a या c की power k की power p and e की power k minus k is equal to c e की power k minus 1 to the power p. Simple, put the substitutions and you would get the answer. And now for Newton-Raphson method. For Newton-Raphson method we have xk plus 1 is equal to xk minus f of xk upon f dash xk. Simply put the values. Epsilon k plus epsilon is equal to epsilon k plus 1 plus epsilon minus f of epsilon. This would be equal to f of epsilon k epsilon plus epsilon k upon 1 factorial f of epsilon plus epsilon k का square f double dash epsilon upon 2 factorial and this would have f dash epsilon plus epsilon k upon 1 factorial f dash epsilon plus f double dash epsilon plus एक epsilon is coming from one epsilon is coming from here, one dash is coming from here, epsilon k का square f triple dash epsilon upon 2 factorial and so on. So now we would have f epsilon is equal to 0 simply because epsilon is the original root. So we have a की power epsilon k f dash epsilon plus epsilon k का square f double dash epsilon dot upon f dash epsilon plus epsilon k f double dash epsilon upon 1 factorial plus epsilon k का square f triple dash epsilon upon 2 factorial dot and here we have this, and epsilon k plus 1 epsilon से epsilon cancelled out is equal to epsilon k, sorry, human needs of itching my ear nice Hindi English है ना. So epsilon k we will take out constant क्या बोलते हैं, we will take out f dash epsilon upon epsilon k as constant and we will have epsilon k का square f dash epsilon upon f double dash epsilon upon f dash epsilon upon 2 factorial plus dot upon here we will take epsilon constant f dash epsilon k f double dash epsilon upon f dash epsilon plus epsilon k का square upon f dash epsilon 2 factorial f triple dash epsilon. Again my ear is itching very much, give me 1 second, human need brother. Now epsilon k plus 1 is equal to epsilon k minus f dash epsilon we will cancel out simply here, and now write epsilon k 1 plus epsilon k का square upon 2 factorial f double dash epsilon upon f dash epsilon dot into 1 plus epsilon k f double dash epsilon upon f dash epsilon dot minus 1. Again 1 plus x to power minus 1 is equal to 1 minus x plus x का square minus x का cube dot k plus 1 is equal to e की power k minus epsilon k 1 plus epsilon k का square. Now we will simply multiply 1 into epsilon k f double dash epsilon upon f dash epsilon minus epsilon k का square upon 2 factorial, no plus here would be come minus after opening, so 1 minus epsilon k f dash double dash epsilon upon f dash epsilon है ना, and this would go on and this, and hence minus 1 is inside na because of this, so here we would have minus 1 into minus and then this into this, so we will have simply e power k of double dash epsilon upon f dash epsilon, and we have not to write, we will not have to write this into this because it will be get neglected out. On solving this we have epsilon k upon 2 in minus f double dash epsilon f dash epsilon, and here we multiply this and into square, because epsilon multiplied by this ka square, into epsilon k. We not have square here, I suppose. Because we have taken out epsilon constant, so one epsilon is taken out, and here epsilon k is this. So we will not have epsilon k. Now we will epsilon k का square, है ना, simply, and minus epsilon k plus dot 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 dot, neglecting here you can write neglecting the higher power terms of epsilon k and epsilon k minus epsilon k f dash epsilon k, है ना, no epsilon k simply, and we will have epsilon k plus 1, and here we would have epsilon k plus 1 is equal to cancel, minus minus plus will get, मतलब multiplied, I did not write it, epsilon k का square upon 2 f double dash epsilon f dash epsilon. We will can write this as constant c, and this will be our p, so p is equal to 2. Order of convergence slash rate भी लिख सकते हैं, we can also write rate convergence of Newton-Raphson method is equal to 2. Simple. So now we will learn about numerical integration. No, first we will learn about this. देखो operators. We can write that. How should I start? We can start with. I remember the formula, but I don't know how to write it. I'm trying very hard with it. We will start with forward difference operator. It is equal to e minus 1. Forward difference operator is equal to f xi plus 1 minus f of xi, and e is generally equal to e of f of xi is equal to f of xi plus 1, I suppose, है ना, and backward difference operator is equal to 1 minus e की power minus 1. And first I will check this thing. Let me check it. So I was correct, this e f xi is equal to f of xi plus 1, and this is equal to this, and we have delta is equal to e की power half minus e की power minus half, and u is equal to this is central difference formula, and this is mean operator, central mean e की power half plus e की power minus half upon 2. With these formulas you will be able to prove anything that comes in the form in the exam, at least I think so. And after this we will do numerical differentiation. It is very simple. Firstly we need to get to think about f xi plus h. We can write f of xi plus h upon 1 factorial f dash xi plus h square f double dash xi upon 2 factorial plus dot 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 dot. From here we neglect the higher order terms. We have xi plus h is equal to f of xi plus h f dash xi. Here we can find f of x f dash I is equal to f of, it is very simple, xi plus 1 minus f of xi. Simply xi plus h is equal to xi plus 1, where h is equal to step size, है ना. So now we have my hand, f of xi plus 1 minus xi. H can also be written as difference between two consecutive terms, and we do the two consecutive terms xi plus 1 minus and xi simply. Now backward, for backward difference formula we have xi minus h, and here we have f of xi minus h upon 1 factorial f dash xi plus h square upon 2 factorial f double dash xi minus dot 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 dot. from here neglecting higher order terms, so f of xi minus 1 minus f of xi here from here upon h is equal to f dash xi, where h can be written as, sorry, this will be plus and this will be minus है ना, minus here, so xi minus 1, simply two terms, two consecutive terms, this will come here and this will cover there, and f dash xi is equal to f dash I minus is equal to f xi minus f of xi minus 1 upon xi minus 1, simple. Now we can simply have f of xi, f of now for central difference formula f dash xi है ना, we would have to add both of this, and if we add both of this we can get simply x of xi plus 1 adding 2 f dash f of xi है ना, f dash xi, so adding these both terms, this we take as h upon h, f of xi minus f of xi, this and this f of xi minus f xi minus 1, simply taking x, because this terms is equal to h and this is equal to h, so simply h, and here we have this minus this, and so f dash xi would equal to 2 will go there, f of xi plus 1 minus f of xi minus 1 upon 2h. This is the central difference formula, this is main formula. All the three are the main formulas. This is forward difference, this is backward difference, and this is central. And now we would have 3-point formula for f dash xi, forward difference. First, forward is equal to minus f of, this we have to learn because this has no proof, xi plus 2 plus, this has proof but this is not in my syllabus, so I have not learned it in Delhi University syllabus, I suppose. So we have been directly given the formula. Here we write f of xi plus 1 minus f of 3 into f of xi upon 2h. I will check this for check so that I don't write the wrong formula, so it is correct. And backward difference we have f of xi. देखो, this is forward because 1 2 3, if you put xi is equal to 1, so 1 2 3 or 0 1 2, and simply if we put if we take xi minus 2, xi minus 1 and xi, we would get backward difference formula, which would be equal to 3 of f of xi plus minus 4 of f of xi minus 1. You simply see that it is generally opposite, simply you have to learn the pattern. If you try, you will able to learn it. I have learned it like this, minus minus, and this minus turns to plus, and this comes forward, and this thing get plus f of xi minus 2 upon 2h. This is backward 3-point formula. This is forward difference 3-point formula. Now for f double dash x, we can simply add this series and this series. We would have f of xi plus h minus f of xi, sorry, f of xi minus h is equal to 2f of xi, and this terms will cancel out, and we will have this plus h square upon 2 factorial into 2 f double dash xi, and higher terms will be neglecting higher terms, we have this only, and we will take it there, f of xi plus 1 minus f of xi minus 1 plus f of xi minus 1 minus 2 of f of xi, 2 से 2 cancel because 2 factorial is equal to 2, h square f double dash xi f of xi is equal to f of xi plus 1 plus f of xi minus 1 minus 2 f of xi upon h का square. This is f double dash xi. And now we will have interpolation For interpolation polynomial, interpolating polynomial, legendary interpolating polynomial comes first. It can be used for unequal intervals, and this it has a pattern like this. You will learn it if we have 2 points x0, x1, x2, x3. There can be many points. You can find the polynomial for as many points as you want. Now see the pattern. Firstly, we don't write the term for in the first, and we will write x everything minus in minus x2, x3, xn, so on. And then we write x0 minus x1, the point we have not written down, x0 minus x1, and then we write f of x0, and simply again repeat this process, x minus x0. Do not write this x minus x2, x minus x3 upon write this x1 minus x0, and simply take that you have taken above, take it down, x1 minus x3 f of x1. Simply now x minus x2, no, x minus x0, x minus x1, x minus x3, and now replace x with x2, x2 minus x0, x2 minus x1, x2 minus x3, and here write f of x2. And simply for last, x minus x0, x minus x1, x minus x2 upon x3 minus x0, x3 minus x1, x3 minus x2, and here we write fx3, simple, and so on. We have also a polynomial like p and x. This my sir taught us is a little trick, not trick, it is simply for knowledge. X, x1, x2, fx1, fx2. Now you can simply when you open it across, open matlab if you find the determinant across the row side, we will have Newton interpolating polynomial for two terms, I suppose, and across column we will have Lagrange interpolating polynomial. Now we have simply Newton forward. Here we have f a plus hu. A plus hu is simply the term a plus hu, where a is the base, h is the step size, is equal to x. A plus hu is equal to f of a plus u del of fa, forward difference operator, plus upon 1 factorial u minus 1 upon 2 factorial fa del square, plus u minus 1 u minus 2 upon 3 factorial del cube fa, plus dot 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 dot, so on. Newton backward, we have fa plus hu. Here we just simply put u plus 1, and here generally used values smaller than is in negative. Fa plus u is there, we have nebula operator, I suppose this is called nebula only. Fa upon 1 factorial plus u minus 1 upon 2 factorial, u plus 1 upon 2 factorial nebula square fa plus u minus 1 u plus 1 u plus 2 upon 3 factorial nebula cube fa plus dot 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 dot. Now we have Newton polynomial for Newton interpolating polynomial for unequal intervals. For unequal intervals, we have f of x is equal to f at x0, f at x0 plus del f at x0 x minus x0 plus x minus x0 x minus x1 del square fx0 plus x minus x0 x minus x1 x minus x2 del cube fx0 plus dot 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 dot. And here we find the polynomial 1 2 this 2 3 4 5 x1 x2 x3 x4 x5 x0, f0, f1, f2, f3, f4, f5. Here we minus this f0 minus f1, f1 minus f0 upon x1 minus x0, and this is f2 minus f1 upon x2 minus x1. And when we do this like this for in the forward, we get this minus this upon x1 upon x2 minus x0, x2 minus x0, and simply we go forward like this, and this here delta terms represent this delta, delta square, delta cube, and so on. And now we will see numerical integration. For trapezoidal rule we have 1 upon 2 fa plus h upon 2 numerical integration, integration a to b fx dx is equal to h by 2 fa fb first term and last term plus 2 into remaining terms, summation of f of remaining terms, मतलब simply f of remaining terms. We have to just learn this formula, and if we have only 2 points, then fa plus fb by 2. This is for trapezoidal, this is the formula for trapezoids, है ना, trapezoids. And if we have three formula, the three points, then the middle point will be multiplied by 2 and added, and h is equal to b minus a by n. Here n is equal to 1. Now simply Simpson's 1 by 3. Simpson 1 by 3. So here we have h by 3 fa first term fb last term plus 2 into sum of odd terms plus 4 into sum of odd terms, 2 into sum of even terms, 4 into sum of odd terms, 2 into sum of even terms. I need to check this formula. Four into sum of odd terms and 2 into sum of even terms. Simpson's 3 by 8. I remember this 3 by 8, and here we have multiples of 3, and here we have interval should be multiple of 2, and h is always remain the same, b minus a upon n. Here b is the last term, a is the first term, and 3h by 8 fa plus fb plus 3 into sum of remaining terms. Remaining of what? Remaining terms that are not multiples of 3, that is plus 2 into sum of terms multiple of 3. So this is all we have got, and then we have Richardson Interpolation. In this we use fxi plus 1 d of h is equal to, simply we use to find fx also here, f dash x here also, but with simply more accuracy up to order 6. First we have order 4, then we have order 6, then we have order 8. This order terms you can see in the simply in a YouTube video, and I am simply defining the formulas. This formula is generally used for finding h upon 2h, and we find dh by 2 f xi plus 1 minus f of xi minus 1 plus h by 2 minus h by 2 upon 2h. This h by 2 is outside this bracket, है ना, and this is ऐसे like this. This is simply like I plus fxi plus h xi minus h, simply this, and we get the new d is equal to dh by 2 4 dh by 2 minus dh upon 3. And if we have more than 3 terms, matlab 4 2 1, this can act like h by 2 for this act like h by 2 for this. We can have two formulas d and d using this two, है ना. We find value of this, we find value of this, then we find value of this d, and then we use this formula and we get this. And for finding furthermore, we use the formula d की power n minus 1 h by 2 minus d की power n minus 1 h upon 4 की power n minus 1 is equal to d की power n dn, मतलब dn next term. This is 1 and this is 2, so 16 d h by 2 previous minus d h upon 16 minus 1 15. Next would be 64 d h by 2 minus dh upon 63, and so on. And now we have Romberg integration. In Romberg integration we simply have h by 2, h by 4, h by 8, and we find I1, I2, I3, I4, and then we can find this, we can find using trapezoidal rule, which is where trapezoidal, which we have found it out to be h by 2 fa plus fb 2 into sum of remaining terms, है ना. And we will find this I1 dash, I2 dash, I3 dash, and I1 double dash, I2 double dash, and I1 triple dash. Now for having this we have V4b minus a upon 3. For this we have 16b minus a upon 15. For this we have 64b minus a upon 63, and for this we have 256b minus a upon 255. Simple. You can pause the YouTube video. What are these? B is simply this term and this term, and h by 2 is, h is simply b minus a by 2. First we start with b minus a by 2, and then we simply go on, and h is simply the step size. We find the values of f for every step, every function, f x I, फिर उसके बाद f of x I plus h by h, f of x I plus h 2h, है ना. For first term we have this, and for second term we have more number of terms, and then we use trapezoidal formula for that also. Generally they ask only for 3 because it is a very lengthy process. And now we have, what I need to add more is that piecewise interpolation, है ना. Piecewise interpolation is nothing. Interpolation, we use legendary simple interpolation simply in normal pieces like 1 2 3 is given and value of function at this is given and this is given. For this interval we find Lagrange's interpolating polynomial for 3 to 5, and then we write 1 to 5 we have this Lagrange interpolating polynomial, 1 to 3 we have this interpolating polynomial, 3 to 5 we have this interpolating polynomial. And if we have to find the value of 4, so f4 would lie into this, and we will write Lagrange interpolating polynomial of this and find the value of Lagrange interpolating polynomial. Thank you and have a nice day. I try to summarize as much as I can, and sorry if I did something wrong. Oh, I forgot to tell you about क्या बोलते हैं the Euler's formulas or Runge-Kutta method of first order. It is also called Runge-Kutta method of first order. It's have simple formula. Yn plus 1 is equal to नहीं yn plus 1 is equal to fx plus h into xn comma yn, and simply Euler's modified Runge-Kutta method of second order. Yn plus 1 star is equal to yn plus h by 2 f of xn comma yn plus f of xn plus 1 comma y star n plus 1 simply, and yn plus 1 star is equal to yn plus h f of xn comma yn. This to be obtained prior by using this formula. And now we have Runge-Kutta method of fourth order. This is a little lengthy process, but it gives us a very nice answer and fast answer and accurate answer. we have k1 is equal to h of xn comma yn, k2 is equal to h of xn plus h by 2 comma yn plus k1 by 2, k3 is equal to h f of xn plus h by 2 comma yn plus k2 by 2, k4 is equal to h f of xn plus h comma yn plus k3, and we have k is equal to simple k1 plus 2k2 plus 2k3 plus k4. Simply these two terms are which middle terms are multiplied by 2 and remaining are this, and total number of terms is 6. 2 plus 2 plus 1 plus 1 6, and here 6, and we have y is equal to k is like the steps of y, so k plus 1 is equal to yk plus yn plus 1 is equal to yn plus k. This is simply like xn plus 1 is equal to xn plus h. Thank you.